Welcome to Homework Lib.
In problem 106, we have a pencil that's located um, 15 centimeters above the optic axis, and that's the center of the pencil here, which is at point C. Let's call that C. The eraser is point A, and the point is point B. Okay, so the pencil is oriented 45 degrees with respect to the optic axis, and this point C, which is like the midway point of the pencil, is located at 15 centimeters above the optic axis, and I've called that point YC. And there is a lens to the right of the pencil with a focal length of 20 centimeters, and we need to find out what are the images of point A, point B, and point C. And then we are also to determine basically how the length of the pencil, and also how the image of the pencil. We're to make a sketch of the image of the pencil when it goes through this lens. So we will apply but just two equations, 1 over s plus 1 over s primed is equal to 1 over f. So we'll use this equation 3 times for points A, B, and C. And then we also want to know how the pencil will be oriented. So we need the images, how the images of point A, B, and C are oriented. And for that, we can look at the magnification, which is minus s prime over s. And this will, if m is positive, then the image is erect. And if m is negative, then the image is inverted. So this equation, and this equation also has another part, m is y primed over y, okay, which we can rewrite m as, we can rewrite y prime as my, okay? And let me directly substitute that m is minus s prime over s. So then y prime, which is the height of the image, is minus s prime over s times y. So primarily, these are the two equations we're going to use. And in another part, we're asked to find the length of the image. And that's an application of Pythagoras' theorem, as we'll see. And that will depend on s prime, which will be the image, the distance of the image from the lens, and y prime, which is the height of the image. So let's go ahead and start solving for the location of the images for points A, B, and C. So the easiest actually is to start with point C. So let's do that on the next page. So for point C, we have 1 over s c plus 1 over sc primed is equal to 1 over f. And we want to find sc prime. In general, I can, if I want to find, let me just write down that if I want to find s prime, that is sf over s minus f, okay? So for sc primed, that's sc times f over sc minus f. SC, we know, I don't know if I drew it in the figure, I didn't, but we're given that as 45 centimeters, okay? SB and SA we don't know, and we also know YC. We don't know YA and YB, but we do know that this pencil is oriented 45 degrees, and we know the length of the pencil, 45 degrees with respect to the optic axis, and that point C is the halfway point, and we know the length. So we'll be able to find SA and SB. But for now, we're working with SC because it's the easiest one. So SC primed is now 45 centimeters times the focal length, which we're given, 20 centimeters, divided by 45 centimeters minus 20 centimeters. And I've written that in my notes here. That's 36 centimeters. Okay, so SC primed is positive, therefore this the image of the point C, which is at the middle point of this pencil here, is 36 centimeters to the right of the lens. Okay, whether it's up here or down here, that will be determined whether or not Y primed is positive or negative. So let's find out where if that is 36 centimeters. Is it up here or down here? So let's continue with that. So we know that YC primed is equal to minus SC primed over S times YC. Okay, and YC we know is 15, and SC prime we just found. SC is given to us. So let's find out what we have here. So that's minus 36 centimeters divided by 45 centimeters times 15 centimeters. And that is minus 12. Okay, so that means the image is 36 centimeters to the right of the lens and 12 centimeters below the optic axis. So that point will be like over here somewhere. Okay. Now let's determine point A. So again, we'll use the same equation, but I'll put the index A now. But this is a little trickier because we need to find out what SA is in order to find out SA prime. So let's look back at the figure. So this pencil is, let me erase this part. So our goal is to find SA before moving on, but just to make things a little bit clearer, let me draw the optic axis. So let's say this is the line here, and the pencil is located like this, and we know this length from here to here. That's 16 centimeters. Okay. And this is my point C, which is the midway point. So this is 8 centimeters from here to here, and also from here to here is 8 centimeters. Okay, cool. And this angle is 45 degrees. So basically, if I look at my figure now, I want to find SA. Well, SA is SC plus this extra bit from here to here. But what is that extra bit? That extra bit, okay, so that extra bit is just from here to here, right? This distance. That is that extra bit that I need to find, and that can be easily found but by pretty much examining that I have a right triangle here. Okay, so let me redraw this part. So what I have is something like this, and like this. Um, and this is 8 centimeters. Okay. And this angle here also will be 45 degrees. And so this is 45 degrees. That's 90 degrees. And I need to find out this length. Okay. So how do I find that length? I don't know. Let's call it I don't know, SAX. So SAX is equal to, or rather you can note this, that the cosine of 45 is equal to adjacent over hypotenuse, which is SAX over 8 centimeters, or SAX is equal to 8 centimeters times 45 degrees. Okay, so now I know that SA is SAX plus SC. We've determined that from the figure, right, that SC is the midpoint, and then I need a little bit more, which I called SAX. So that little bit is LP over 2, which is 8 centimeters, times cosine of 45 degrees. So then SA is SC plus SAX. And that is 8 centimeters cosine of 45 plus 45 centimeters. And that gives me, let's see, I've written it here. That gives me 50.7 centimeters. Okay, so now that I have SA, I can again use this formula to find SA prime. So then SA prime is equal to SA times F divided by SA minus F, right? So that's 50.7 centimeters times F, which is 20 centimeters, divided by 50.7 centimeters minus 20 centimeters. And that gives me an SA prime of 33 centimeters. Okay, so again, SA prime is positive. I'm 33 centimeters to the right of the lens, right? So my eraser is 33 centimeters to the right. Now, how is it oriented? Is it up here? Is it down here? Again, we'll use this equation to figure that out. So same procedure that we followed in part C, but it's a little bit more complicated because we need to figure out YA just as we figured out SA by using a little bit of trigonometry. So let's add a new page. Okay, so YA is equal to minus SA prime over SA. Sorry, that should be YA prime times YA. But we need to figure out what YA is. Okay, so let's go back to our first figure. YA, you can see that YA will be YC minus, so YA goes up to here, and YC is there, so it's minus this little bit. Let me draw that in a different, put that in red. So YA is YC minus this little bit over here. what is that little bit? Well, it turns out that it is this height. So let's call that y a, I don't know, um, lowercase a. Okay, so we call that y lowercase a. And that will turn out to be, so y a then is 8 centimeters times sine of 45 degrees. Right, so what did I use? I used sine of 45 is equal to opposite over hypotenuse, which is ya over 8 centimeters, right? And then I solve for ya by moving the 8 centimeters to the left side. So ya is 8 centimeters sine of 45 degrees. And so, I mean, that little bit, right? That y lowercase a. Now, y uppercase a is yc minus y lowercase a, which is that little bit here. If you look in the figure, that little bit in red is the y lowercase a, right? So then yc minus y lowercase a is y uppercase a. So that we know that's 15 centimeters minus, and then ya now is 8 centimeters sine of 45 degrees. And that gives me, ya of, let me see, did I write it down? I think it just, you can compute this easily, but I could just kind of lump it all into the final stage where I compute ya prime. So ya prime is minus sa, which is 33 centimeter, sa prime rather, divided by sa, which I have somewhere, 50.7. And then that times ya, which is 15 centimeters minus 8 centimeters times 40 sine of 45 degrees. And that gives me a ya prime of minus 6.10 centimeters. So ya is down on this side. All right, so now again, we'll repeat the same procedure for part C, where I have now SC prime is going to be SC times F over SC minus F. And if I plug in, well, then I have to find SC and SC, sorry, SB, point B, we already did C. My apologies there for my mistake. And then SB then will be SC minus this little bit here, right? Or SC is that little bit plus SB. And how do we find that? Well, we technically have already found what this little bit is, which is exactly what we have done here. It's the cosine of 45 when we use this. So that will be the same as SAX. It could be SBX, which will be 8 centimeters times the cosine of 45 degrees. So then SB is SC minus 8 centimeters cosine of 45 degrees. and that gives me 40.7 centimeters. So it's 40.7 centimeters to the right of the lens. Similarly, we want to find YB primed, and we're going to use minus SB primed over SB times YB, and YB will be equal to YC plus sine 8 centimeters sine of 45. Why? Because whereas YA was YC minus that little bit in red, YB is going to be YC plus that little bit in red, as you can see up here, right? And that little bit in red, we already figured out that's 8 centimeters times sine of 45 degrees. Okay, so my YB primed is minus SB, which is 40.7 centimeters divided by, I haven't found SB prime, sorry. So using this formula, you find SB primed, and SB primed is, so I made a mistake here. So this is SB. SB is not 40.7. SB is 39.3 centimeters. And SB primed, using this formula and using this value for SB, you get 40.7. So I will strongly urge you to calculate the numbers yourself. The formulas are correct, but I might make a mistake in when I plug in my calculator or when I copy from my notes. So as you follow along, make sure that you are plugging in the numbers yourself to make sure, just in case I make an error, that you will not make the same errors that I'm making. So I will reiterate that the formulas are correct, but I might write down the wrong numbers, and I will try to be as careful as possible. Okay, so now, so that's 40.7 divided by 39.3 centimeters. And then we have YC, which is 15 centimeters plus 8 centimeters times sine of 45 degrees. And that gives me a YB primed of minus 21.4 centimeters. Okay, so we have figured out basically where points A, B, and C are located, both in the X and Y direction. The X direction are taken into account by the image. For the image, right? They're taken into account by SA prime, SC prime, and SB prime, right? So that's for the X direction. In the Y direction, we have YA prime, YB prime, and YC prime, right? And all of these X values are located to the right of the lens, and all of the Y values are located below the optic axis. So the image will be somewhere over here. But before we do that, let's figure out how long our pencil is now. Let's do that. So the new length, the length of the image, I'll call that, so I call the length of the pencil LP, and I'll call the image LP prime. Well, you're going to use basically Pythagoras' theorem for that, right? So it'll be delta x squared plus delta y squared. And my delta x is the difference between the tip, the point of the pencil to the eraser that's formed by the image. So that's, let's go back to the initial picture. It'll be my SA minus SB So let's write that here. So that's SA prime minus SB prime. And my delta Y is YA prime minus YB primed. Okay, and these numbers we have calculated over here on this page and on this page. And I'll just reproduce the numbers here. So then we have 33 centimeters minus 40.7 centimeters squared plus 6.10 centimeters minus 21.4 centimeters squared. And that gives me 17.1 centimeters. So that's the length, the new length, the length of the image of the pencil. And now, how is it oriented? So we have the optic axis, which is, imagine that's straight, and then your pencil is up here like this, and it looks something like that. And we have the lens over here, and then the image now look something like this. So we had A, C, and B, A, C, and B. And so this is A prime, that's C prime, and that's B prime. Oh, sorry, I messed up my figure. It looks like this. So the orientation is like this, right? So that was A, that's C, and that's B. This is A prime, that's C prime, and that's B prime. So this is a sketch of how it will look.